Lesson 3.1, Integer Exponents. So we only have two vocabulary for today, and that is exponent, which is going to be this number up here, and that is just a way of writing how many times this number, the larger number, or the base, is going to be multiplied by itself. Okay, so the base is your original number, right? And the exponent is telling you how many times that should be multiplied by itself. So 5 to the second is the same as saying 5 times 5. Okay, properties of exponents. So you can look at the table right here that I made. Any base, right? So right here we're looking at base 10. Any base raised to a 0 is going to be 1. All right? Any base raised to the 0 power is 1. And for every time you increase your exponent, you're multiplying by your base one other time. Okay? So anything to the first is just itself, because that's the base times 1. Anything to the 0 is 1 because you're not multiplying the base at all. It's just 1 times and then there's nothing else. Okay? So every time you increase, you're going to multiply by the base another time. So 10 to the second is 10 times 10 times 1. Okay? We often will drop the 1 because it's just going to have the same result as doing 10 times 10. But when we go into the negatives, it becomes important, and it's easier to see if we have that 1. So every time you increase the exponent, okay, every time you go to the left on this table, we are multiplying by 10, okay, or multiplying by the base. In this case, it's 10, but we're multiplying it by the base. All right. Every time we go to the right, so we're decreasing our exponent, or going closer towards negative exponents, we are dividing by 10. And you can see when we've simplified it, all the way over here, 10 to the second, we have 100, 10 times 10. If we go back 1, we reduce our exponent by 1. We divide by 10. 100 divided by 10 is 10. 10 divided by 10 is 1. 1 divided by 10 is 1/10. 1/10 divided by 10 is 1/100th. Okay? When you have a negative exponent, you are going to have the same value as your positive exponent, but it's going to be underneath a fraction. Right? So 10 to the first has 10 times 1. 10 to the negative first has 1 over 10 times 1. Okay, same thing for 10 to the second. 10 times 10 times 1. 10 to the negative second, 1 over 10 times 10 times 1. All right? So simplifying negative exponents. This is probably the first time you've really seen a negative exponent. And it's really pretty simple. Like I was saying, it's the same value as that same base to the same power if it was positive. But now it's going to be under 1. It's going to be a fraction. Okay? So your first step is to write your division bar with your 1 in the numerator, and then your base in the denominator, and you're going to be multiplying that however many times you have that exponent. So 10 times 10 times 10 times 10 times 10. Okay? And then the last thing is you need to simplify that. So that's going to be 1 over 1 followed by 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5. And we have 1/100,000ths. Okay? You can also express these as decimals, and you can make that conversion pretty easily because it'll always have 1 in the numerator. And if the base is 10, then it'll be easy to express that as a decimal because it's going to be converted really nicely, right? You can do that by dropping as many zeros as you have in this number, right? So I have 5 zeros, 2, 3, 4, 5, then dropping your 1. Okay, so you're kind of reversing it. However, you need to put that decimal after the first 0. Okay, it's a little trick that makes it easy to do. You can also just do the normal conversion, so that you can just count it off: tenths, hundredths, thousandths, 10,000ths, 100,000ths. Right? I have 1 100,000th here, and I have 1 100,000th here. Okay. We won't always use 10 as our base. Sometimes we'll use other numbers. And sometimes we will have a negative number that we'll be using. Okay? It works the same. So for this one, I have 1 over, and then I have negative 3 times negative 3 times negative 3. Oops, negative 3. Okay? For this one, same thing, 1 over negative 3 times negative 3 times negative 3 times negative 3. Okay? When you have a negative base, if you have an odd, and it doesn't matter if it's positive or negative, but if you have an odd exponent, your answer is going to turn out to be odd. If you have an even exponent, your answer will be even. The reason for that is we're multiplying, right? And if each of the numbers we're multiplying is negative, we are going to take away negatives for each pair, right? Because a negative times a negative is a positive. And when we have an even number, we'll be left with all positives when our exponent is even. When our exponent is odd, we're going to be left with 1 negative hanging out there at the end, and that's going to turn our whole answer negative. So this one's going to be 3 times 3, 9 times negative 3, 1 over negative 27, right? And this one, 3 times 3 times 3, 27 times 3, which is 81, okay? And it's positive. There you go.